how preparing quality diagrams to present your thoughts and ideas is very important while writing a research article, be it a journal, conference, or be it your thesis. Okay. So, considering the importance of drawing in research writing, I requested my colleague Professor Suraj Kumar Behra, who on our request agreed to give his time to present on this topic, where he will be explaining the importance of drawing in research, and he will help you to know some fundamentals which will help you in the long run. So now I request Professor Behra to take on this test. Thank you. Online participants, please confirm whether you are getting my voice or not. Online participants, are you getting our voice? Please respond.
Yes, sir, getting your voice.
Okay, so good afternoon to all, and today, as Professor Maharana has already explained, in the next 1 hour we'll be studying something called role of drawing in research methodology. So, as you know, drawings are very extremely important to convey or to communicate with reviewer, with other people who are reading your articles. So we cannot neglect that part. This is also one of the major part in preparing any research document, any project proposal, any poster presentation, any any sort of article related to research. So coming to why for research documents and presentation, this diagram is an important one, or this good diagrams are important. First point is communication. So communication, as dictionary says, literally the meaning is the act of communicating. That means we want to pass certain news, we want to pass certain feelings, we want to pass certain information. So in those cases, communication is essential. So as of now, I guess different types of communication you must be knowing something called visual and audio. Audio usually as a technical people, you want to avoid audio type of communications because it leads to confusions. So for accurate understanding of the or accurately communicating your thoughts to the other people, the best one is the visual. Again, with visual we have sequential, like step by step you'll write down all the concept whenever you are writing articles. At the same time, you'll have pictorial meaning it's just like a photograph type of things you have taken, but they do not give exactly dimensions of your drawings. But one more thing is technical. Under technical, you must have read in your first year undergraduation something called engineering drawing. And if you are from mechanical industrial design, then you must have read something called machine drawing, production drawing, assembly drawing. So there are different type of, even patent drawing is there also. So patent drawing meaning, suppose something new you have invented, you want to communicate that you have invented, but still you do not want to disclose every component of it. That time also how to do those things. So those things can be also done by, at presently, earlier it was extremely difficult, but nowadays we have many softwares who can do for you also. Okay, we'll be discussing one by one. So now, so basic statement is technical drawing is the language of engineers or designers. So we'll be dealing mostly with this sort of technical drawings, which will be easy to communicate, that is to without any sort of ambiguities, any sort of confusion. So that is our target. Next coming, this figure, you must be aware of the different type of or categories of knowledge in the research methodology. So if you see one of the most important one in the left hand side in the model, you'll see it's a picture. When I say picture, picture meaning there's some sort of diagram type. They mean to say that. Okay. So picture, it's old Chinese proverb says, a picture is a worth of thousands words. Like what you cannot explain clearly in words, picture can explain it very nicely to you. So that is the point of this phrase. Okay. So engineer graphics or drawings, these are all compulsory in the first year with a ambition that it provides a perspective to look at the things. Like what you are thinking about the objects. What about, suppose you want to design a test rig, how you want to design a test rig, how the line diagram has to be drawn. All these concepts we'll be discussing one by one. Now, what is the need of good drawing? Let us come to the main topic. What is the need of? There are different areas where we will be needing drawing in our research work. So, if you want to write a review article, you can draw it. If you want to write a journal article, you can draw it. You want to attend a conference, you want to prepare the presentation, then project presentation, a poster presentation, even project proposal writing. So anywhere, all these major areas I have told you where you can write down the research methodology. I mean, these are part of the research methodology where good drawing is essential. Now question comes, what do you mean by good drawing? As I said, the clean statement is free from ambiguities, free from any sort of confusions. The reviewer or anybody, any other reader who is trying to understand what is there in your mind, he should not have confusions. So it should be a very clean message should go to him. That is the reason we are interested in this session, that how to draw the good drawings. So now question comes, what are the areas as a researcher? What are the areas normally as an engineer? What are the areas where drawings are necessary? First thing is you want a good test setup. Suppose you want to draw a test setup. You want to communicate, this is how we have developed a test setup. If you give a complete figure of it, there will be confusion, because if you take a photograph of it and you just paste it, there will be confusion. You need to say exactly where is the pressure tank, where is the valve, where is the temperature measurement equipment, sensor, blah blah blah. So one of the major area is drawing for testing. This is one of the way of presenting the drawings for testing. And now it is a multimedia age. So you try to take the help of something called Microsoft PowerPoint. So this is done simply using Microsoft PowerPoint with arrow marks. Everything is given. The flow of, suppose this is related to my work. That's why I've given this one. So here it clearly indicates which are the what components. You will also mention it here. You will mention which one is the component and which one is the measuring devices, and you can name them one by one. Okay. And if any this part is the exaggerated part of this whole system. So this is given a importance where I will be working on. So those things also you can explain. Innovative approach can also be made by you, that how to do it. And this can be easily done by Microsoft PowerPoint. All the blocks will be available. I'll show you if you have confusions. I'll show you how to draw it towards the end of the session. And second comes, even better than that, if I can draw in PowerPoint something like this will be more attractive. Especially these sort of drawings are expected in project proposals. They whenever reviewer thinks like has the principal investigator understood the concept completely, how to do the experiments. So if you provide this sort of clean diagram, it clearly indicates how to go for this. And this can also be done. It only thing is that you have to keep in mind, if you see these figures, some of the figures, these are the real figures or these are the solid modeling figures. It has to be copyright violation should not be there. That means what do you mean by copyright violation? If these equipments are available in your laboratory, take the photograph, remove the background, then give it, add it here. Understood? It is not, I mean, from the website, if it is companies, no problem. But if it is from a research article, problem may be there. Okay. So that's why you try to avoid as much as possible. Okay, that one you have to. And if it is available in your laboratory, then it's well and good. No problem, no problem. Because you have purchased it, that is your asset now. So no one can get a question. And if it is from a company, and that is not a problem, they're disclosing it openly. Okay. Apart from this one, today's we are here to discuss something later. If you see this test setup, this one shows more accurately, and with dimensions also you can, I mean to the scale also you can tell to the reviewers, or you can write in your research articles easily. So here it is clearly says that you have complete idea how you are going to test it, or if you have already tested, you are writing a manuscript, then how it has been done. So this can be easily done. One of the solid modeling software called FreeCAD. Okay. Apart from that one, this can also be done in MS Word also, but that will be very time consuming. But solid modeling software, if you learn any sort of basics of solid modeling softwares, there are many free softwares also, then easily. And if you are from any engineering institute, there must be a solid modeling software like SolidWorks, AutoCAD, or CATIA, something will be there also. And apart, this is how to draw a test strip. And sometimes people in their manuscript, they used to give the complete experimental setup like this. But this also create confusion. Okay, this gives a indication. This is also necessary, but this setup will give a idea to the reviewer that yes, they have the setup in their laboratory and they are doing it. But this is still I will say this is an unclean diagram. Along with this one, I repeat, along with this one, if you provide a solid model setup like this gives a very clear indication that yes, this diagram, the person who has done it, he has understood it. Also, the people who will be reading it in future to your article, they can easily understand, they can set up their experimental setup according to your ideas. Okay, and this can be done in, this has been done in one of the software that is called SolidWorks. SolidWorks. This software is there in our institute. I guess most of the institute used to have it, have this sort of a solid modeling software. So then, if you want to draw any machines, any machine components, mechanism, all these things. So again, you can go for solid models, something like this. If you see, this is a solid model, but still it doesn't give us the internal parts. If you want to show the internal parts, which is a valve, which is a turbine, which is a compressor, which is a bearing, or which is a shaft, blah blah, everything, which is a seal. So that time you can draw it, and this can be drawn. This drawing this one doesn't take much time also. 1 day, 2 day time is sufficient if you have learned a particular software, any software, any solid modeling software. It's not subjected to that you have to learn only this or only that. But based on availability, again I say, if you have purchased SolidWorks, then learn it. If you have purchased CATIA, learn it. If you have purchased AutoCAD, learn it. Institute have purchased it, or organization has already purchased. And most of the places, it has been purchased. Even private institutes also, they have purchased. And one more is that you have to give a naming convention. Only giving the model is not sufficient. Exactly, you have to give name, or try to give names 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then exactly say, and it also says you which component is after which component. This clearly says. Okay, so this is one of the way to provide a clean diagram in your this one. Okay. Then comes this is one more. This is called exploded view. Exploded view helps to find out what are all the components. You can think of any area you are dealing with, if you are fabricating any machinery or any components, you can give a exploded view easily. This is a very complex job, still exploded view has been given, is clear. And people will come to have a very clean idea that which component is after which component. And you can also give the naming convention 1, 2, 3, 4 and write down in the right hand side. 1 is for this, 1, 2 is for this, 3 is for this, 4 is for this, and this. These slides also I will share with you, so you can take the help of it. Okay. Suppose you want to draw any sort of specimen, you will be testing different type of specimen in your research, practical research area. So that time you can draw the specimen. In the specimen, you can give accurate dimensions. So dimensioning is very important here now. That is what I wanted to point out in the slide. Now question comes like how to draw all these components or solid models. This one. So the ultimately what I am trying to say is solid modeling is anyhow important for a good drawing or error-free drawing. That is the primary motto of drawing anything. So you talk of any branches, you will be dealing with machineries. You will be dealing with experimental test setup. You will be dealing with test specimens. So solid modeling is important. So next one is sometimes you used to have ambiguities and questions. Like many times you have read engineering drawing in your first year, but even if you give those drawings also, confusion will be there. I have a small question for all of you. Like suppose you have heard about something called front view, top view, right view, left view, all these things in a first year.
In AutoCAD, sir.
Sorry.
In
Yes.
AutoCAD, sir.
In AutoCAD also you can do it. What is your question exactly? Can you tell me? Repeat it.
No, sir. No question, sir.
Okay. So my question here is just to understand you. Like suppose the front view is a square. Inside that there is a small square, and top view is a square. Inside that small square. So can you think of how the object will be? Can you think about the
Sir,
object? How
it is
yes, sir.
cubical.
It's cubical.
Yes, sir.
But in cubical, if it is cubical, inside that there is a hole, again cubical hole, then problem will be there must be a hidden lines, right? Any edges which is not directly visible, we provide hidden lines, but I don't see any hidden lines.
Yes, sir. Yes, sir.
Yes or no? So you try to think about it. Yes. Tell me.
It's like this, sir.
Sorry? Huh?
Okay, sir. I have to draw and show you, sir.
Okay, you can later on you can discuss with me. Also, I have the solution here. You can check the solution. So here, the point of placing this question to the audience is even engineering drawings are also sometimes can be complex if you don't do it correctly. If you don't give the proper views, engineering drawing is also leads to ambiguities. But solid model can erase those ambiguities also. So question is, if I ask a question to all the audience, is it a solution? Yes, no, or maybe?
Yes, sir.
Sir, no, sir. No, sir.
It's correct, sir.
Sorry, yes. Okay,
Yes,
some
yes,
people
sir.
are
Yes,
saying
sir.
yes, some people are saying no. Then my answer is maybe, because this can also be one of the answer. That's why I'm saying maybe, because if I go for this sort of solid model, this can also be a solution for that
Yes, sir. Yes, sir.
front view as well as top view. Exactly, you are getting those lines. Again, you try to recall your engineering drawing knowledge. After this session, you will get all the answers. But still, I have a question: is it yes, no, or maybe?
Yes, sir.
Yes, Mm, I'll say maybe, because one more solution can be this one also.
Hmm.
So, point I'm saying is that sometimes even engineering drawing collapses where solid model has its own benefit. Again, I'll say, is it yes, no, maybe? This can also be a solution. Okay, so point of saying is that very clean way I'm saying is you try to learn a solid modeling software, and learning software is maximum takes 1 to 2 weeks time. If every day 2 hours you provide time for it. Okay, so that is and my teacher is nobody but YouTube. I learned SolidWorks from YouTube only. So you can take the help of YouTube. Many tutorials are there. And if you need my guidance also, I will also provide you which component to be drawn fast, so that it will be easy for you. Okay, I have been teaching for this sort of courses for last couple of years. So anytime you can take my guidance. So finally, if you give a complete view with proper dimension, then only things will be correct. It will be then only free from ambiguities or free from doubts. So as of now, we have learned that solid modeling is necessary. Some of more basic benefits. Let us try to understand. Suppose you wanted to draw, even if you have a very good idea about orthographic projection views, cutting section views, still many times the views at the left hand side in the slide is completely complex one compared to the right hand side. Here people can easily understand, and if you want to provide dimensions, then you have to provide dimension of each part. But you can see this right hand side view is very clean compared to the left hand side. So this is one of the benefits of solid modeling, that is clean assembly. One is, suppose you want to go for exploded view. In the left side, it's a complete assembly. Now, in the right hand side, you have the exploded view. So these sort of views are available in any software, solid modeling software you learn is available. Okay. And suppose you want to give simple simulation that one rotor is rotating, others are starters, one rotor is rotating. So you to upload this one in your manuscript. There is also provision if you are writing a journal article. It's not that only figure you have to give. You can also upload. You have that provision in almost all journals. Upload the animated file, GIF file, then any videos. Understood? So you can take the help of this sort of animation file and get the approval from the reviewer easily. And this is one assembly. Suppose you want to show the assembly of all inner components one by one. This can be easily done in the solid modeling software. It's earlier it was very complex to do those things, but nowadays you do not need any sort of certification in videography or something. Basic any intermediate student also can draw all these things. Okay, today we'll learn learn how to draw a simple model. I'll tell you, and you will have confidence on how to learn these softwares also. This is one of the, we call it turbo expander. We have fabricated it, and this is how this part of a BRNS project. So this is also, if you want to go for bigger views, you can go for complete assembly view, assembly simulation. It exactly say which part is what and how they are going to be joined. This is a one-time job for you. Remember, this is a one-time job for you while writing the proposal. After that, this can be used for your fabrication also. This can be used for your project presentation also. This can be used many places, wherever you can think of. Okay. Then any simulation, assembly simulation, these are the real work which has been done, and we wanted to communicate to them how assembly has been done. So there are ample of examples you can find out. Okay, this one is important because while writing project proposals, this set of drawings is, if you provide, you will have a very good impression. The reviewer will have a very good impression. This has been done in simple SolidWorks softwares. Every part has been drawn. After that, they have been assembled. And if you see, there is something like motion study. This sort of things can be easily done, as well as it can be uploaded into the manuscript site also. Okay. So these are all motion studies. It clearly indicates if you rotating with the clockwise, then it is going down. If you rotate with anti-clockwise from the top, it will go up. And calculation can also be shown. Okay. So you can try to correlate these things in your actual research area where you are doing. This is what I am giving example in my research area. Suppose you try to correlate it, you will surely gain the knowledge of it. Okay, next one is 3D modeling software. 3D modeling softwares, there are 50 or 60 type of 3D modeling. Which one to be done? If your institute have a particular software, go for it without hesitation. It doesn't have it, go for a free software. Understood? So modern software, one of the simplest, it can be done by school children also, that is called Tinkercad. That is a free software where many models you will find out in the download section also. You can download from them. But normally people use for gaming purpose, blah blah, all these things. So if it is okay with you, go for it. But you can draw that any sort of test setup you talk about. One more free software. These are good free software I'm talking. This is one of the best. It's called FreeCAD. But this is free with up to certain features. All the features are not free. But I am sure I have used this software, and this is very easy to learn also. And you can draw any test rigs, test specimen, any sort of model, figure or drawings you want to make, you can easily make it. Okay. Even you want to make a logo, you can do it easily. Now coming to Paisawala software. Okay. These softwares are costly. Never try to purchase by yourself. Okay. So you give a proposal to your institute if they have not purchased. Show them these slides. What is the importance of drawings to our engineers? Then they will surely purchase it. I think is there anyone from any other institute?
Yes, sir. I am from NIT Agartala, sir.
So is it available in your any solid modeling software?
No, sir. Cracked version is available.
No. I'm talking about solid modeling software. It must be available. You try to talk with. Are you from mechanical or some other branch?
Mechanical, sir.
So talk to your HOD. There must be a software.
Solid work is there, sir.
SolidWorks is there. It's a very beautiful software. So try to take the help of the SolidWorks. Any Any help you need, you can discuss with me. That means try to use this sort of feature in your research work. Then only it will be more robust. So this is a AutoCAD. Similarly, you have SolidWorks. SolidWorks, this is one of the top solid modeling. But in industry, you may not be finding SolidWorks much. CATIA is one more software which is mostly used. Okay. Every software has certain advantages and limitations. So the design depend on the design engineers who. So these are some of the Creo, then IronCAD, CATIA, again SAP 3D, Fusion 360, popular software. Apart from them, you have many other free softwares also. Again, so you need not to learn more than any. And one thing I want to say you everyone, if you learn one software only, the same concept is used for all the software, because this is how the software has been. The theory behind creating that software is same for everyone. If you are from mechanical engineering, then you must have learned something called we have learned computer aided design. So whatever the theory is there, that is same for everyone. Understood? Okay. Next thing comes is it necessary to draw all the solid models? Sometimes to save time, there is a community where almost most of the things you will find out. Suppose you want to find a compressor model. Easily you search in the website that is called grabcard.com. Grabcard.com. I am 100% sure you will get that model available there. You can edit it slightly, dimension you can edit it, then you can use it. Understood? Grabcard. This is also whenever you are making solid any models. My sincere request is you also contribute to this website. Someone else will also use it. Understood? So this is how the solid modeling community will improve day by day. Okay. And also there is one more site, something called remove background from the image. You need not to learn CATIA or some softwares to remove background. Sometimes there will be unnecessary background. Suppose you have taken a photo, then you want to remove background also. So this site, something called remove.bg. This is a very good software. I mean, sorry, very good website which removes the background within fraction of minutes. Okay. So try to take help of this set of things through online mode. Okay. But today I will talk about something called SolidWorks. Why I am talking about SolidWorks? Because we have that software. It's not that it's a good software or bad software. We have the software in our institute, and I will tell you, and that same principle will be used for every software, whichever you will learn. So this is solid modeling software is used by millions of people in different companies. Then it has many features like an innovative way to solve project challenges. It has the ability to import data and translate and store it securely. Then it has a simulation software which will help you to do any sort of simulations. Also, it has animations facilities. So those things. So now SolidWorks dealing with this solid modeling software is very choosy. So I choosy in the sense, suppose you have drawn something in SolidWorks 2021 version. Now, if you want to open it SolidWorks 18 version, it will not open. Understood? So even pirated things will be available somewhere. So don't download from that. Okay. But the point of saying is that if you are dealing with lower version, then it will open in the upper version. But vice versa is not possible. So at present, SolidWorks 2021 is there, and its version number is 02, which was released in January 11, 2021. So now the basics of solid modeling, simple concept. I'll teach you in next 5 minutes. I'll teach you solid modeling basics. First, you have to draw a sketch. Suppose you have to draw a cylinder. That is a 3D feature. So how to draw? Simply select a plane. Let us say this is my plane. I'll draw a circle. I'll give a thickness. Done. Again, suppose I want to make a cuboid. Make a rectangle on a plane and give a thickness to it. This is exactly. This one says me exactly. Now draw a sketch. When I say sketch, that means drawing that rectangle is the sketch. And it has to be drawn on a simple plane surface. Rectangle has to be drawn in a plane surface. It cannot be drawn on a curved surface or something like that. So you have to select a plane surface, then draw a rectangle, then give a thickness to it. When giving thickness to it, that is nothing but 3D part we have given. We call it in solid modeling language, we call it providing a features to the sketch. Providing feature to the sketch, nothing but 3D. So once 3D part is done, job is done. Next part is you can bring it to a better 2D drawings. Then you can assemble if multiple parts has been drawn. So today in next 15 minutes, we'll learn the basics of this one. Like let us draw this one simply using SolidWorks. This is a simple object, and if you see complexity, I mean I don't see any sort of complexity. This is what I am supposed trying to develop. Okay, so this is nothing but a cube type of hollow cube is there. Above that one hollow cylinder is there. Then some circular holes are there above this. So how to draw it? How to draw it in any software? First of all, you have to draw a sketch. I'll explain by opening the SolidWorks software also. But before that one, let us see some of the slides. How I will do it. Okay. First of all, you have to select a plane, then draw a sketch. When I say draw a sketch, a rectangular sort of hollow rectangular type of things has been drawn. Then give a thickness. So once you give thickness, it will become this one. Clear? This part is clear. Now the upper part need to be covered. So again, over this one, you draw a rectangle, square. Then because the dimension is 100 by 100 here, 100 by 100. So this is a square shape. Again, on this surface, you draw a square. Then give a thickness. So once you give thickness, it will become like this. So now over this surface now become a one more plane for next drawing. This surface, on this surface you provide a circle, then give a thickness. Then what you can do is you can draw one more circle and cut it. Instead of giving material to it, you will have that is called extruded cut. This is a solid modeling language. Extruded boss meaning giving materials to it. Extruded cut meaning removing material from it. Understood? So now it is done. Next one is I have to draw a small hole here. Simply make a circle, cut it. Once you have drawn it, because repeatedly, instead of doing repeatedly, suppose 8 number of such holes I have to make here, then I can use something called circular pattern. In circle, the pattern will be followed with equal space. So done. Understood? So let us learn it. Let us learn it quickly. This is a SolidWorks software. To start with, first of all, let us go to file. Listen it carefully. This will be very simple. I'm just telling you that how simple this can be to learn a solid modeling software. It's not at all difficult. If you are able to learn MATLAB, you are able to learn Simulink, then this software is nothing before them. Okay. So now go to new. You can give the dimension, whether millimeter, gram, second, blah, blah, all these things. Okay. So now if you click on OK, the home page will come now. Now it will ask you what exactly you are trying to do. Are you trying to draw a part? Part meaning simple component. or you are trying to do assembly, that means you are trying to add different components which has been already drawn, or you want to do the drawing. Drawing meaning 2D drawings. That means already model has been created. Now you want to import those models to a plane of paper. That means front view, top view, right view, left view. So these ones. So suppose we want to go for part. This is the beginning stage part. Okay. Click on OK. So once you click on OK, now by default, 3 planes will be coming, because as I said, 3 steps for drawing any solid modeling. One is select a plane. Second is draw a sketch. Third is give a feature to it. Either give material or remove material from it. So now suppose I have by default I have front plane, top plane, right plane. Let me select the top plane. Now top plane will be selected. Let me make it normal to me. Top plane is this one. So this is, you have to imagine that way. Now you are looking from top of the object. This computer screen shows me the top of the object. So now simply go to sketch, go for rectangle, simply click anywhere you want, but better to start with the origin. That will help you to decide many times. Click it here and click it anywhere. Now I know this will be 100 by 100. No need to give dimension now. Simply give smart dimension. Click on this line. Once you take it to the line, it will be highlighted. Take it to the line, then again click it here. Give 100 millimeter. Why it is millimeter? Because I have selected it. This is millimeter. Okay. So you have to take, it can be inch, it can be inch, meter, centimeter, but I have to do millimeter. Similarly, still in the cursor, if you see, the smart dimension icon is still attached. So that means I can again give dimension this side, which is nothing but 100. Done. So now I can enlarge my screen by using scroll keys, something like this, scroll keys. So this part is done. So this is now 100 by 100. I have to, suppose I will, because I want to create a hollow one. So I can simply create one more hollow. Start anywhere, stop anywhere. Then give thickness. I know the thickness is 10 mm as per my requirement. So give thickness 10 mm here. Simply write down 10, it will take, because by default it is taking millimeter. This side 10 mm. This side 10 mm. So all the side thickness is 10 mm now. 10 mm. This side 10 mm. Okay. This side 10 mm. So now if you see, very uniformly it has been placed here. So now you have done with the sketch. So now you are done with sketch. So now this is the sketch. So once sketch is done, then select the sketch. Select the sketch. That means click. Select meaning click. Left click on the sketch. Then go to feature. Go to extruded boss. As I say, extruded boss meaning giving material. Extruded cut meaning removing material. I want to give material to it. Extruded boss. Now it will ask you in which direction. Are you want to increase in this direction or in this direction? So that control is also possible here. Here something like both bi-direction also can be given also. Bi-direction can also be given also. This one. So let me repeat it. Go to sketch, go to feature, extruded boss. So now you can give here dimension on the left hand side, that how much length you want, how much height you want. Let me say 110 is my requirement. 110. So now it will ask you that this block is done. Click OK. Now this block is done. Next target is to close this one. Again, select, as I said, 3 steps. Select a plan, draw a sketch, give a feature. So select this plan, then go to sketch, start from here. Once you take this one, this point will be automatically highlighted. Click here, Other click can be when it is highlighted. Done. Automatically, it is taking that rectangle, that square. Then this part is done. Sketch is ready. Sketch is also selected. Go to feature. Go to extruded boss. Now, suppose I want to give extruded boss in the downside side by 10 millimeter because thickness is 10. So change the direction to this side. Give thickness to 10 mm. 10 mm. Enter. Then done. So now you can rotate it by seeing arrow keys. This is done. This is done. You can using arrow keys, you can rotate it the way you like. You want to come back to the isometric view? Come. This is my isometric view. That means this is my front side, this is my right side, other side is left, this is my top side. Isometric view will be. After drawing any model, I generally tell students to come to isometric. Now next one is cylinder. I want to make a cylinder. Go to this one. And I'm saying this is not the only way of drawing this one. You can think of you can start with cylinder. You can start with solid cylinder, make it hollow, or you can start with the hollow cylinder directly. This one. So let us make a solid cylinder simply. So I want to draw sketch. Go okay. First of all, 3 steps. Select the plane. Go to sketch. Anywhere you can start. Anywhere you can start. You need not to worry about dimension. Automatically it will be adjusted. How it will be adjusted? Make it normal to you. Make it normal to you. So now suppose I know this diameter of the circle need to be 50. This need to be 50. And it has to be at the center also. To keep in the center exactly this distance, the center to this distance need to be 50. And similarly, the center to this distance need to be, sorry. Let me repeat it. Center smart dimension, select this one, then select this one. Again, let me draw it. Select this one, select this one. This distance need to be 50. So now you'll see it is exactly at the center. Okay. So now next target is I can give a feature to it. Go to this one. You can rotate it by using arrow key, and you will see this one is trying to move. Okay, it is going in the right direction. Otherwise, you can give this direction also. Now I want to give 50. Suppose let us say I want to make it a 50 height. So done. So once this has been done, our next target is to create a hollow one. I have to create a hollow one. So select the surface, go to sketch, go draw the circle. Now, if you take here, this is the center now. It is clearly showing. So you can give directly dimension, or you can give thickness of this, and this is nothing but, let us say 5. So done. So now this sketch is done. Left hand side sketch is done. I have to go for extruded cut because I want to remove material. Up to how long you want to remove material? You can draw this one, or simply you can through all. That means whatever comes in between, simply cut it. Done. So now you can see if you want to rotate it, you can see this is almost we have done. Last feature is left, some holes. Now next target is again come back to the isometric view. Isometric view, this one. So this is front, this is right. So now I want to draw suppose circular hole here. So there is no such plane here. You can insert a plane here, or this is a plane you can find out here. So take this one, then make it normal to you, normal to you. Okay. So now go to sketch, go to small circle and draw it here. Simply give, let us say this one is 10 mm. And the distance from here to here, smart dimension, the distance from here to here is 25. So it will come to the exact. So now what I'll do, you can see here exactly at this place, you have drawn it at this place. So now select the sketch, go to feature. We'll go for extruded boss or extruded cut to make the hole. Extruded cut. So now you can cut it thoroughly throughout this one, or you can drag it up, suppose up to this point I want to do it. So click. So you have made one hole. Such 8 holes suppose I want to make it, or 10 holes I want to make it. 8 holes I will make it. How to do this one? Select this feature which has to be repeated. Because a pattern type is nothing but a circular pattern. Select circular pattern. Now about whom you want to rotate. This shows direction 1. About this circle I want to rotate. Equal spacing you want to give. Okay. So now how many you want to give? Suppose let us say I want to give 8. Click OK. Done. Okay. This is done. So now you can see it's clearly our objective, major objective is done. But I want to give a realistic view. So if you want to give realistic view, first of all save it with a certain name. Then there is something called material. So right click on material, then you can edit any material you want. Any material, variety of type, new material also you can give. Let us say this is some sort of steel, suppose. This is cold roll steel. Then apply. All physical properties will be added to that one. And beauty of this one is if you are dealing with ANSYS or any other simulation software, you can import this one directly into that software. Understood? So this one. Now the color is changed also. It is more lucrative compared to the previous one. This is the educational version. That's why the color doesn't look so good. But in industry, it will look exactly like iron steel. Understood? So now still suppose you want to give a better view or you want to render the figure. That time you have the options, something called go to tools. Many options are there here. Slowly you can learn whichever is necessary. You need not to learn everything. Add turns, give a photo view. Okay. So now after that go to render, go to final rendering. You want to add some camera, suppose we don't want to do it now. This one you will see, you will get a more realistic photo. Now you will get more realistic photo. Okay, so this is how the solid modeling is. Very simple. It will take some time, but see, this is it will give a material type look. Okay, so this is showing you exactly the way the material looks like. So if it is necessary as a photo you want to give in your manuscript, you can easily give it and it will look good. You want to do an animation of this one. Animation is also very easy. Animation ke liye, from here you can do any sort of animation. You want to suppose simply rotate the model, explode the model, collapse the model. Many things are there. Then go for next. Suppose you want to rotate by counterclockwise, you can go for this. 10 seconds you want to rotate. Okay, finish. So now if you start from here, you'll see it starts rotating. Now you capture this view, capture the view. How to capture the view? Capture the view. There is one more software that is called Snagit, which I use. Snagit. Okay, you can download. That is not used. So there you can capture the view also. Here also there is option for save animation. You can save the AVI file or any MP4 file, MP3 files, whatever is there. Okay, so those options are also there. So whichever suitable to you. Okay, so this is how, point of saying is that you can learn the things for research methodology, try to give some more effort learning modeling software, then it will be certainly helpful to you. It is basically give a extra dimension to your thought. Whatever project proposal you have written till now, you add a simulation file like this, I am sure it will give a added advantage to you. So that is basically exactly 3:30. So this basically I wanted to say. And to make your understanding on solid modeling software, I'm conducting a 5-day workshop on December 19 to 23rd, 2022. Okay, and this is already uploaded in the what do you call website, institute, our institute website. You can, if you and your friends wants to attend this, okay, I will be extremely happy. But only problem is the seat limitation is only 50. On special request you can add something, but because this is a hands-on workshop, you will be taught how to do it. My students will be present completely. This is a 40-hour workshop. This is, you have to work before the system only. No lectures for this. I will be giving you lectures how to do blah 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 blah, but no lectures like those will not be there. I am the sole. This is only physical mode. ऑनलाइन में 2 साल तो देखे ना बच्चों को क्या किए वो लोग, है कि नहीं? So I want to conclude at this point. Any questions? Certain reference I have taken, and any questions you have, I will be happy to answer it. हाँ, ऑनलाइन में क्वेश्चन कुछ है? Online is online.
Thank you so much, sir. Myself, Gaurav Kumar from
Yes.
NIT Raipur. Sir, you are explained very well. I watch very carefully.
Okay.
That will be very benefit for doing my PhD. Thank you so
Okay.
much.
Thank you for your kind words. Anybody else? Any doubts from offline? No. Yes. No. See, research, different type of research we do. I'm talking of, suppose you are dealing with metallurgy, or dealing with chemical, dealing with ceramic people. We do fabricate certain type of machine. Sometimes we fabricate. Sometimes test setup we fabricate. है कि नहीं? Experiment तो करते हैं everybody. So how do you convince the reviewers, or how do you convince reviewers that this is the experimental setup you have done? Understood? So that is how you can use the help, take the help of the solid model, or else PowerPoint PPT also I have told you, that is also good. If you are not able to learn these softwares, it's okay still. But you have to give the line diagram the way, colorful line diagram the way I have told you. Okay, that will surely give an impact to you. Anything else? Okay, thank you very much.
Thank you, sir.
Yes, only modeling. Simulation in SolidWorks, simulation is also available. Simulation of suppose stress analysis, thermal analysis, buckling analysis, vibration analysis, those are also available. But I suggest don't go for it. If you have ANSYS, go for it. You can import this model into ANSYS, then do the simulation. Model wise, this is a very good software, but simulation wise, but down the line, maybe after 10 years, this software will be smart in both, like modeling as well as simulation. ANSYS has a problem. Modeling is very poor.
Actually, they are independent software. When it comes under one company, they give a brand name, but in principle, it says they are different software.
Yes, that is also correct.
For example, NC student, NC was a separate company, student was a separate company. Student company exporting similar thing. NCC there is copy of this company, solidworks. They are objecting to create drawing from it. So they purchase that software, they leak inside and through GUI only we are able to see the single software. Actually, they are not single software, they are independent.
Yeah, they will start. Even this SolidWorks software was initially developed by a MIT student, है कि नहीं? तो वो बहुत पैसा कमा लिया, फिर he sold it to Dassault company. Dassault company, you know, the Boeing जो बनाते हैं, Germany company, है कि नहीं? So now they are also Amir. These people are also Amir, है कि नहीं? Okay, thank you very much. Nice audience.
Thank you, Mr. Vera, for giving a very nice wonderful presentation and realizing our participants how drawing is important and how beautiful drawings you can create, more beautiful than Mona Lisa. Okay, and this is very essential. I have already told you many times. Okay, and as I told you, drawing is a language engineer. You have been told first of your BTech program, but they never told that this is what you use really in your future. Okay, so already you tried to manage some. Okay, thank you. So here we have a small program of appreciation from our participants. Whoever joins or not joins, I will join in your program as a free participant.
Okay. Without working lunch. अभी क्या है next? English. Next is English. ऐसे जो कागज আছে এগুলো লেখা है। हाँ, okay, thank you. এটা नहीं जाता हूँ। उठे दिखला मित्र को। नहीं जाता। अच्छा,